Thank you so much, Manuel, and thank you to DevOps Lisbon for allowing me to present today. I was going to do a demo at the end of my session today, but unfortunately we're having some VPN troubles, so I can't get log into Git to actually do the demo. So I'm going to try my best to show you with some screenshots that I already had available to kind of go through the process of what it is that I wanted to show you. So I'm here today to talk to you guys about how Linedata kind of streamlined our CICD, primarily from an infrastructure perspective. So when you think about DevOps, right, it's a lot of the focus is usually on getting software faster into production, providing business value, generating revenue, business value add activities. And although infrastructure as code is a big part of DevOps, it oftentimes gets overlooked, right? Who on the team manages infrastructure? How does the infrastructure actually get deployed? And so what I wanted to talk to you today is give a little introduction about Linedata and what we do, how we have chosen to implement DevOps at Linedata, how we enabled our teams with continuous infrastructure as code using Harness and Git. You don't have to use Harness. You could use Jenkins. You could use other orchestrators, but we just happen to use Harness at Linedata. We'll talk about what GitOps is fundamentally if you haven't heard about it, and then we'll kind of review some of the benefits. And as I mentioned, I won't be able to do the demo, but I'll do my best to try to simulate it as much as possible. So we at Linedata, we are a global financial services company. And what we do is we provide asset managers, wealth managers, lending and leasing, banks, abilities to service their customers. So essentially we provide financial software to major banks and wealth managers all over the world. We are a global organization and we have 20 different offices all across the globe. And as you can imagine, when trying to implement a DevOps culture and a DevOps methodology, having this many offices across this many different time zones and different teams was a challenge. And so we had to think about things a little bit differently. Because we're not only one single organization, Linedata comprises multiple different business units. We have lending and leasing, we have asset management. Within asset management, we have multiple applications. Within those applications, while we're undergoing our digital transformation, we have multiple teams as well. So we need to be able to enable the entire organization to work on Kubernetes, Amazon, specifically around Lambda functions, Azure, event sourcing, and CQRS. So there's a lot happening at Linedata, and we needed to figure out a way to increase our velocity, get our new functionality into the hands of our customers, while also maintaining a certain level of governance and security and SOC 2 compliance. So when we looked at DevOps at Linedata, it was when I first started, we took a look at how did we want to approach DevOps at Linedata. And thank you to Manuel for this diagram. I've been using DevOps topologies with great success for quite some time. And when you think about when organizations, when they try to undergo DevOps for the first time, the first thing that comes to mind is, okay, I need a DevOps team and I need to hire some DevOps engineers. Well, unfortunately, yes, you can do that, and you can do that with great success. But over time, if that skill set does not come into the development and operation teams natively, what's going to happen is that you're just going to further segregate the development and the operations teams. And now you're going to create a silo in between that is now going to be responsible for building all the scripts, troubleshooting the scripts, executing all the scripts. DevOps is supposed to be about enabling teams for self-service and autonomy, following the COMS framework, culture, automation, lean, metric sharing. Everybody's supposed to be working together. But unfortunately, what usually happens is that you'll get great success during the first 3 to 6 months. But then after that, as more teams start to adopt the technology, more teams start using it, you're going to put a higher burden on this DevOps team that you are now going to have to scale. So when we wanted to see what we wanted to actually achieve at Linedata from a DevOps perception, speaking specifically about automation, We knew we wanted continuous integration, deployment, delivery, right? We wanted smart automation, but we also wanted infrastructure as code. We didn't want to have the waterfall model of IT while trying to deliver software in a continuous fashion. Because if the infrastructure is not available and you're having to wait for IT or somebody to provision that for you, then you're going to greatly impede the velocity of your actual deployments. We knew we wanted continuous verification. We wanted the ability to use machine learning and artificial intelligence to verify our deployments. We didn't want to rely on humans reading the test results of a unit test, or the test results of QA testing or automation testing, or even after going into production. We wanted that to be done as part of the pipeline through automation without any human intervention. We wanted continuous security as part of our pipelines, which means security embedded not only into the deployment of the software, right, doing CVE scans and SAS scans and DAS scans, but we also wanted to embed continuous security into our infrastructure as well. And so what that means is, from the very beginning, security is built into the infrastructure. So when you think about AWS, you have to deploy IAM roles for your applications. You have to deploy networks, VPCs, NACLs, security groups. All of that has a high impact on security, encryption. And so we wanted to make sure that our teams had a self-service model where they could enable all of this themselves and have security be a first-class citizen as part of the automation. And finally, we wanted to manage our cost inside of the code, because if you're deploying infrastructure through code, then you can also manage the cost of that infrastructure through code. And what do I mean? Well, when you spin up a Kubernetes or an EKS cluster, you can have on-demand nodes, you can have spot nodes, you can change the instance sizing. And when you start dynamically provisioning infrastructure, you can also shut it down when you don't need it. Because if you think about the cloud, it can be either really expensive or really cost efficient, depending on how you use it. So if you treat the cloud like a traditional on-premise infrastructure where everything always stays on, then it's going to be very expensive. But if you automate the provisioning of your infrastructure as part of the delivery pipeline, then you can destroy and recreate it at will, essentially creating dynamic environments. But ultimately, what does this come down to? It comes down to self-service. We wanted all of our business units, all of our teams, to be able to maximize their productivity through a self-service model with minimal dependency on other teams. So instead of having that central DevOps team that would write the scripts, troubleshoot the scripts, help the teams, we wanted the teams to be able to take this on themselves. Now, when you're a global organization, we had to figure out a way, how are we going to do this? So essentially, we developed kind of our own DevOps topology, but it's a mix of the infrastructure as a service, the platform team, as well as the SRE team. So if you think about how we're structured, we are a global organization. And so at the global level, we have our platform engineering team. What this team does, its sole responsibility is to develop reusable modules. So when teams need to deploy to AWS or Azure or GCP, whether it's a Kubernetes cluster or if it's a cluster in AWS or a cluster in Azure or even GCP, we want the teams to be able to get up and running quickly with modules that are already available, pre-configured, security baked in, ready to go. They just push a button and they're able to deploy and have all the resources they need in order to move forward. Then at the business unit level, we have the traditional kind of SRE model. The SREs run production and collaborate with the platform team. DevOps collaborates with the platform team as well as development. And so what this allowed us to do is, because we were using a lot of the same technology, just a little bit differently, it allowed us to create common modules and scale across the entire organization very, very quickly, and enabling self-service across all of these different teams. So when we think about continuous infrastructure as code and how you handle the deployment of the infrastructure as code, you have to think about it from an automation perspective, right? So some organizations, when they first start out and they start automating, they might do something that's very individual and it's there to make their job easier, right? I do a repetitive task, so I am going to create automation to make my life easier. And that's good for that person, but that doesn't necessarily scale to the team, and it doesn't necessarily scale at an organizational level to provide that scalability. Then as you begin to mature, you start to get a little bit more opportunistic. It's team driven, right? So now you're developing automation that helps a team. Then you go into systematic, and finally institutionalized and adaptive. Now, adaptive, we're talking about Netflix, Facebook, right? Machine learning everywhere, artificial intelligence. It's what companies dream of becoming in terms of automation. But if you get to a level 3, where you have a portfolio of tools and platforms that is widely used across an organization, you get to a point where you can very quickly increase your productivity because everything is so reusable, and you have expertise that you can shuffle around between the different teams, and everybody can help each other and work autonomously within that particular team. Because deployment scripting in itself is not continuous delivery, right? Now, I'm using Jenkins here as an example. I think Jenkins is great. However, it all depends on how you implement it. And so if you have this disconnect between who's deploying applications versus who's deploying infrastructure, when they're deploying it, who's responsible for deploying it, it's hard to keep things in sync and be able to tell, the state of that infrastructure and whether or not, it's where you need it to be. Typically, in this type of scenario, you'll have your DevOps engineers that are responsible for the automation, the scripting. They'll be executing scripts as part of the deployment process alongside the developers, but it's not a seamless, continuous process. Instead, what we wanted to do was we wanted a modular approach, right? So we decided to use Terraform as part of our infrastructure as code model, primarily because it fits so well with GitOps, because it's declarative and it has a state. But what we knew we wanted was we wanted layered modules that could sit on top of each other, right? So if I deploy a VPC and I need to reference that a subnet in that VPC or a security group, I can use the output and I can build on top of it. And so teams are able to layer on top of one another. We want it to be dynamic, right? Reusable. We wanted these modules to be reusable, not targeted scripts that somebody built to make their life easier. We wanted security to be part of the infrastructure as code, and it had to be auditable, right? We have to pass SOC 2. So we need to make sure that we can audit every single change that goes into production. And I'll show you how we're able to achieve that with GitOps. Tagging is a big part of cost allocation, being able to shut things down. We wanted to make sure that tagging was part of the infrastructure provisioning process to make sure that everything was appropriately tagged, not only for billing, but also so we can shut things down at night by using flags such as auto shutdown and a schedule. And we would have scripts that would run on a daily schedule, target those tags and shut things down. We wanted the approvals to be automated. First, we started with auto manual, and then now we're looking into how to automate the approvals. And as I mentioned, change control. We needed a new way to manage the changes to this infrastructure. A standard weekly change control where people get together and find out, what is it that's changing? What are we doing this week? That's not going to cut it, because it's going to interfere with the continuous nature of the application deployment itself. And so what we ended up with is, again, we use Harness for this. You can implement this using other tools as well. But essentially, the platform engineers would write the modules. The developers would consume the modules as part of their delivery pipeline. So if I needed let's say I needed an RDS database, or I needed some part of infrastructure in order for my application to function, I could deploy that as part of my pipeline, right? I didn't have to wait for somebody else to deploy it for me. My pipeline knows that in order for me to deploy this application from scratch, right, from nothing, I need, I need an RDS database. I might need Lambda. I might need some security groups, some roles. All of that would be prepackaged in different Terraform modules and embedded into the pipeline. And so that allowed us to create these dynamic pipelines that included infrastructure as part of the deployment process. And all of that was managed in Git using a branching strategy for different environments, right? So we had dev, QA, staging. We had another structure where we would do it based on the account, depending on what the repo was for, but it was all maintained within a separate branch that would identify that particular environment, and all of these branches were protected via pull request. Could be multiple approvers for production, but you couldn't approve your own pull request, right? Standard pull request branching protection strategies were put in place. And so in order for us to be able to manage those pull requests and be able to deploy this infrastructure, we needed to find a way to make it automated, and we needed to find a way to embed it as part of our pipeline. So if you haven't heard of GitOps, it was first coined by Weaveworks, cited on the bottom right here. If you're looking to hear more about GitOps, feel free to take a look at Weaveworks. But essentially, if you haven't heard of GitOps, it describes the desired state of the system in a declarative language, right? It's stored in Git, and all changes to the desired state are approved Git commits. That's pretty much it. Any change that you need to make, you declare it in Git. I want 5 EC2 instances. I want this security group. This is what I want. I make a pull request for that change, and all changes to the infrastructure don't happen until that PR is actually committed. When you make that PR, this should trigger something to happen, right? So I have my code. I make a pull request that I want to change something. That needs to trigger some sort of change that is going to take the desired state, which is my pull request, compare it to the observed state, which is what's in code now, and then figure out a way on how to converge the two together. And finally, I wanted to be able to roll back my change, right? Let's say I put a change in, but then something broke, right? My monitoring solution sent out an alert, something happened, I need to be able to revert. So because these changes are idempotent, if you want to go back, then you would need to revert your commit and open up another pull request to go back to the previous state. What this happens is that it keeps track of every single change that was made, whether it's a roll forward or a roll backwards. Each commit is unique, and each commit defines what was actually requested in that particular change. And the operating model basically looks like this. You have your Git repo is the single source of truth of a system's desired state. The GitOps diffs compare the desired state with the observed state. Because we use Terraform, this is called a Terraform plan. I have something running now. I want to change it to something else. Terraform plan is going to run, and it's going to say, okay, what am I going to do to get you to your new desired state? Am I going to create something new? Am I going to destroy something, or am I going to change something? Terraform plan will tell you what it's going to do. Once that goes in effect, all of the operations are then committed, and the difference between the observed state and the desired state lead to a convergence. And that's when you run Terraform apply, right? So once you decide that this is what I want to get to, I'm going to run Terraform apply, and I am going to apply the changes that I want to apply. In this type of scenario, all of the changes, they're observable, verifiable, audited, and they have rollback. So if you need to do SOC compliance, where you have to be able to track who changed what, when, where, why, GitOps allows you a very simple solution to be able to track any changes that actually went into production for your infrastructure without having to go back and look through IT tickets and change request tickets. Why was this requested? Who did it? How did they do it? And most importantly, your code becomes your documentation, right? If somebody asks you, okay, how did you do that? You can just look at the code and the documentation will be there available for you as long as you know how to read that code. So at the end of all of this, going through all of this process, what were we able to achieve? So we essentially achieved a self-service model. Again, we used Harness. We ended up in a scenario where all of our different teams were deploying in Harness. Our developers were deploying, our QA team was deploying, our sales and product teams were deploying. If they needed to show a demo or they needed to, work with a client, they could log in and they could deploy a complete environment from scratch, right? They would deploy the networking, the databases, everything that they needed for a demo environment. And then when they were done, they would shut it off. They would completely destroy it. And obviously our SREs and our platform engineers who are responsible for, running production and writing the code, they would be checking in new modules and approving pull requests if anybody wanted to change something in production in the environment. And so this allowed us to quickly accelerate feedback between the business and the development team, and even inside the development team between dev and QA. From, kind of from a benefits perspective, these are, some rough numbers, but because of the dynamic nature of our infrastructure, because we were able to provision, destroy our infrastructure, we cut our AWS bill by about half. Because if you think about it, if you're running something 24/7, right? Let's say instead of running it 24/7, you run it 9 to 5. Right? Or let's say you just cut it down to 12 hours a day and you only do it on Monday through Friday and you have weekends off. If you run 12 hours Monday through Friday and you shut off weekends, you can save 65% off of your Amazon bill for anything that you destroy. We were able to provide visibility into all of our cloud spend by using all of the tagging that was part of the infrastructure provisioning. And we increased our agility by being able to enable the teams with self-service. And our efficiency was increased as well because we were able to realize a return on the investment much quicker because we weren't duplicating efforts across the different teams. We were reusing modules and scaling with those modules. And from a cultural perspective, basically we improved the quality of life of our developers. We were able to let the developers focus on writing code instead of worrying about automation. We had a template library that everybody could reuse along with those modules. And we really were able to achieve this self-service model in supporting our global teams. But it didn't come without challenges. The design and implementation of GitOps is not trivial. It does take a good amount of effort in order to set everything up, make sure that the repos are set up, the webhooks between your Git repo and your orchestration engine is set up, make sure the repos are protected properly. It takes a little bit of time, and there's a steep learning curve, right? So developers might not know about databases or networking or IAM roles, right? They're still learning, but because DevOps fosters collaboration, this is actually a benefit in disguise because it forces the developers to work with the operations teams to begin to understand more about what it is to run operations. And it takes discipline. It's very easy to try to create something manually without having to go through the GitOps process, right? I just want a server. I just want an instance. So it does take some discipline to make sure that everything goes through the GitOps process to make sure that it is a idempotent process. But the benefits, you get a self-service IT. If you know how to make a pull request, if you understand the infrastructure, if you understand Terraform, you can make your own pull request and request a change without having to put in a ticket, right? Approving a PR is always going to be faster than taking a ticket, finding out what needs to be done, doing the ticket, and then going back and forth between the developer trying to figure out what the requirements are. You get transparency because it's in code, so everything is documented. You know exactly what is going on and what's happening inside of your code. As I mentioned, you get this collaboration between the dev and the ops teams because they have to learn about each other's principles. Developers need to learn about operations, and operations needs to learn about development practices like Git, like source control. We are able to scale because we're able to reuse modules, and we were able to streamline our entire process. We embedded security as part of the pipeline, whether it's IAM roles or networking security. And again, we were able to increase our return on investment. Now, this is the part where I wanted to show you guys the demo, but unfortunately, as I mentioned, it's not available. But I'll try to kind of show you what I was going to get at. So we have a Git organization with branches, with repos and branches set up. We use Terraform for our infrastructure as code, which is modular. We use Harness as our orchestrator, and AWS is going to be the target infrastructure that we're deploying to. So what it looks like is something like this. I know it's a very busy diagram, but we'll follow by the numbers. So if you know what you're doing, you can create a pull request. That pull request then automatically triggers a Terraform plan. That Terraform plan writes back to Git with a comment with a link to the plan that you can then click and verify that what you put in is either syntactically correct or it's doing what it is that you want to do. And let's say you made a mistake. You can continue making changes inside of your branch, and it will continue to synchronize. So every time you make a commit, it's going to run a Terraform plan, and it's going to tell you what is it that your desired state is going to be. Once somebody approves, then it goes and it runs a Terraform apply. And so it writes back to the Git comment, so that way you can go into the apply and actually approve the execution of the apply. Why is there an approval? Well, PR could be approved at 2 in the morning. It could be approved at 2 o'clock in the afternoon. So instead of just rolling something out, we wanted to be able to let the requester have some control over when they want to implement that change. So they've requested it. It's been approved in Git, and it's going to execute the Terraform plan, wait for an approval, and then once the requester approves it, it's going to execute a Terraform apply. And the way that we actually execute the apply is we have a central AWS account that is used to execute all of our Terraform, and we execute across account across all of our organizations. So we have dozens and dozens of AWS accounts, and these Harness delegates that we have running inside of this central AWS account is able to assume the role of every single AWS account to execute on that change, allowing us to maintain governance and security around, these DevOps delegates and this account and what this account has access to. From a Git perspective, as I was mentioning, so you would create your patch branch, you would raise your pull request, it would automatically trigger a plan. You would wait for the pull request approval and then merge your change. Once your change is merged, then you can go ahead and execute the apply. And if you can see on the bottom right hand of the screen, you'll see a link there from SA-AMP build with a link to Harness. That is the link for the execution of the Terraform plan. And so what we created was this bi-directional link between Harness and Terraform and Git, so that anytime you make a change, it's able to synchronize and give you immediate feedback on what that change actually is going to be. So thank you guys so much. I hope you enjoyed that. And again, I apologize for not being able to show the GitOps pull request in action, but I hope you were able to at least enjoy this presentation and how we implemented infrastructure as code as part of our pipeline and incorporated into our GitOps process.
Well, first, this was a great presentation. I really liked the subject, and I think it was very well explained. I have too many questions, so if I start to hijack the session, please stop me. I probably will start with the with something that I may missed during the presentation, but you, Andrew, mentioned machine learning and artificial intelligence to enhance or even mature your process around security and verification and probably cost management as well. Can you just comment on that a little bit to explain a bit more, please?
Sure, absolutely. So I will preface this by saying, I'm sorry, Louise, this is not a pitch for Harness. However, we specifically chose Harness that has this capability. So what we didn't want is, if you think about a traditional pipeline where you deploy something and then you need to verify the deployment, right? You need to know whether or not it's successful. You need to understand whether or not there's problems with it, or if you introduce something unnatural into the process. So what we wanted to do was, instead of having humans rely on reading the results of an automation test or looking at a dashboard, instead what we did was we integrated Harness with our log system, and we enabled the Harness tooling, which comes out of the box with this machine learning, and it's able to tell us whether or not there was an issue. So as part of the deployment, every time we would deploy something, Harness would go and basically start to scrape the logs and look to see what was happening. And if there was an error or if there was a failure, it would trigger that automatically, and it would have an algorithm where it would know if something was, whether it was new or if it was a known issue. And we even went as far as, instead of just looking at the logs, we created our QA automation of the actual code, provide a structured result, and Harness was able to parse that structured result, whether it was a success or a failure, and apply its machine learning mechanism and algorithms, and be able to decide whether or not the verification passed or not. And if it didn't pass, we would, perform some sort of automated action. And if it passed, we would continue on to the next phase.
Okay, got it. From the cost management perspective, you're talking about tagging, which is fine, a common approach for you to understand which resource they're using for that specific area or cost center. How do you control that? Do you have a baseline, or do you have any kind of visualization tool where you can see that cost that's supposed to be and where it is at that specific point in time? How does that work?
Yes. So again, I'm not here to advertise for Harness. However,
okay.
Harness does have a continuous efficiency module that allow us to look at our cost from a granular perspective. And so what we did was we created basic reports and alerts on reports that did not have peaks and valleys. And so when this goes into the FinOps approach, managing your cost as code. Basically, we, by default, we would use a tagging mechanism to define whether or not something could be shut off at night and on the weekends, right? It was just a Boolean flag auto shut off. We would then have a Harness workflow that would run on a schedule that the team defined, right? So the team was responsible for their schedule. And then during the the stand-ups and the governance meetings, they would take a look at a Harness graph, and we would make sure that there were peaks and valleys. And if there weren't peaks and valleys, then the team would have to go back and take a look and make sure that they were implementing this properly. But essentially what we did was we gave the product team all of the tools and automation to manage this themselves. And we allowed them, or the product managers and the delivery managers, to manage this within the team. So this self-service model allowed the team to be autonomous and manage their own cost.
Okay, can they see the report via Harness, or is there anything else that you use to see the report?
So Harness, they use Harness because Harness is able to aggregate not only our Kubernetes costs, but also our AWS costs. So we were able to aggregate everything in one place. And we actually used, this goes into this FinOps conversation that I've been doing. We tagged our namespaces in our infrastructure to be able to correlate the namespaces with the infrastructure associated. So I'll give you an example. If you're deploying a Kubernetes application and you have a QA namespace, that application might have associated infrastructure. It might have an RDS database. It might have some S3 buckets or some other AWS services. How do you connect the cost between the namespace and the infrastructure as well? And so what we did was we tagged the infrastructure with the namespace, and we used that tag to aggregate the cost across the entire application and be able to do reporting and cost projection on the application as a whole, not just the different parts.
Got it.
Okay.
Thanks.
Thank you. Good questions. So we have a couple other questions in the chat from Nuno Justo. First of all, he's saying it was a very, very nice presentation. And the question is, you did not say how you can roll back, but I assume it's just a commit revert.
Yep, that's exactly, you are 100% correct. Because that change is stored in Git, it's just as simple as doing a commit revert, which then triggers the pull request process all over again. And you're able to reapply what was there previously before you made your change.
And another question from Miguel Teixeira. Is there any strategy to the test orchestration that you recommend?
I'm not sure I fully understand the question. But from a test orchestration perspective, what we wanted to make sure was that we captured all of our testing, our test results in a place and in a structure that we could parse. So we used XUnit for our .NET testing. Most of it was written in C# using XUnit. And we made sure that we captured the results in a JSON format that we were able to then easily parse using machine learning and be able to use that algorithm for the verification.
Okay, thank you, Andrey. So I don't see any other questions. Okay, we have one more from Patrice from Ericeira. Hello, nice presentation. On the organizational perspective, could you explain a bit how teams are organized and the team topologies, and how the different roles you mentioned operate and interact, dev, DevOps, SRE, and platform engineering?
Manuel, do you want to answer this?
No, your specific context.
Yes. So we'll start at the top level. So the platform engineering team essentially doesn't belong to any R&D team. It is outside of the R&D process. Essentially, it is an IT team, right? It's an operations team, and that team sits at a global level, and they interact with the various business units through different ways. The team itself operates on a sprint basis because they're there to write code, right? They're not there to do operational tasks for the team. They're there to write code and approve PRs. So the team works on a 2-week sprint. They have stand-ups where other business units are invited. Other teams are able to put Jira tickets into the backlog for either module enhancement or or a new module that needs to be created, or moving to, let's say, Terraform 13 or AWS Provider 3, whatever it is, they would create these requests. And so the platform team and the SREs and the DevOps DevOps folks would collaborate together. A level lower would be the SRE. The SREs are within each and every product team has an SRE team. And the SRE team is a pretty standard Google SRE team. They run production and they get to decide whether or not something is ready to go to production. So if you're using the modules and the frameworks that the platform team developed, then it's very easy for you to get to production because all of the security, all of the monitoring, everything is part of the framework. However, if you don't use the framework and you try to go to production, that's where the SREs can step in and say, no, this isn't ready because it doesn't meet the security guidelines. It doesn't meet the monitoring guidelines, whatever that may be. And so they're there to protect production. The development teams and the DevOps is a function within the development team. It's not a separate team. It is individuals within the team that are evangelists that lead the team using, the comms framework between culture and automation, lean, metric, sharing. They're there to enable the team and help out with any kind of the day-to-day tasks that might be needed from an automation perspective, but they are developers. They write code. They do not sit there and write scripts on behalf of the development team. They are part of the dev team as a developer.
Thank you. So we have a comment from Mona. First of all, nicely done. And then a question. Did you integrate any sort of security scans such as Vercode for dynamic security analysis? Something that runs on every build deployment?
Yes, we do run a variety of security code scans depending on the framework and the application. We run Vercode. We run Deep Fence. We scan containers for CVEs. And we've also started scanning our Terraform code for security as well. So there's new startups and tools out there that allow for dynamic and static code scanning of your infrastructure as code. And we've started to incorporate that, those types of scans as well.
Thank you. And one more question from Ricardo Sanch. How much time it took to implement this model?
Well, it depends on which model you're talking about. The team topology and the DevOps model, it took us probably about a year of maturity, right? It's not something that we said top down, this is the way that we're going to function. It was more of an iteration. We started with a pilot team, see how it went from there, and then we gradually began to expand organically through a grassroots type of campaign. And so our concept was, instead of restructuring the company or restructuring the teams, we wanted to show the value of what this type of model can deliver. And once we were able to provide that that value and show that value, more and more teams started to pick it up, and it kind of became organic. And then that's when we realized that we needed the platform team, because we had so many different teams working together, duplicating code, potentially not following best practices. That's when we formed the platform team. So it was an iteration of maturity as we began to kind of find our place in a DevOps world. The GitOps model, that took us probably 3 to 4 weeks. Again, not with Harness, and because it's continuous delivery as a service, and it enables GitHub Actions and webhooks. Setting up a standard GitOps repo process probably took us a couple of days, and then from there it was just expanding it to other repos and other teams, and getting everybody on board and trained with the process.
We were talking about security and verification / compliance at development time, deployment time. So you verify your code when you're building and deploying. What about runtime? Do you have any mechanism that verifies your infrastructure at runtime?
Yes. So we use a variety of tools to verify our infrastructure at runtime. Because we're, let's say from an AWS perspective, we use a combination of Trusted Advisor, AWS Config, Security Hub. So we use a lot of the tools that Amazon provides, and we incorporate those that scanning as part of our infrastructure. But we also use a other tools to scan our Kubernetes infrastructure in order to make sure that the containers are complying as well. But essentially, there's a variety of tools that we use, and most of the tools that manage the actual infrastructure, not the application or the containers themselves, though we use the Amazon built-in tools for that, and it's worked out pretty well for us so far.
Perfect. Thanks.